Hello and welcome back. In this video, we will talk about literals. But before I get started, I want to talk about what we have covered in the last couple of videos. So the last video was dedicated solely to data types, and the video before that was dedicated to understanding how data types, literals, and variables work together. So think of the second last video as a high level overview of all of it working together. Now, the reason I made such a video is because data types, literals, and variables are intertwined, and it is very hard for me to explain each one of them in isolation. And if it is hard for me to explain, it obviously will be harder for you to understand them in isolation because we cannot really isolate them. So we're going to start with literals, but if at any point you feel like you do not understand what's going on, I would suggest that you pause this video, go to the second last video, take a look at it so that you get a high level view, and then come back to this video. It will start clicking. If you still do not understand, feel free to put your questions in the comments. So with that said and done, let's get started. Now, in the second last video, we came across a statement which was int num1 is equal to 10. And we had discussed that this 10 over here is a fixed value that we are assigning to the variable num1. And the fact that this is the fixed value being assigned to num1 means that unless and until the value of num1 changes somewhere down the line in the code, this is going to remain assigned to 10 itself. Now, the fixed value that we see over here is called a literal. Now, what exactly counts as literals? Are literals just integers or are there more? To answer this question, let's recap a little bit and talk about what we had discussed when talking about data types. So we had discussed that there are 8 primitive data types available in Java. And these primitive types are also called as simple types. Now, these 8 primitive types, which are byte, short, int, long, float, double, char, and boolean, can be categorized into 4 groups. And they are integers, floating point numbers, characters, and booleans. And other than the simple types, Java also makes available something called complex types, of which string is an example. Now, if we were to write an example of each of these categories, what could it be? For integers, it can be 10. For floating point number, it can be 3.1415. For characters, it could be, say, a dollar symbol. And for Boolean, it could be, say, true. For string, it could be hello world. Now, if you have already noticed, all of these are fixed values that can be put directly in the code. Like how we did for 10, saying int num1 is equal to 10, we could do the same thing for floating point numbers. We can say maybe float, which as we know is one of the data types that supports numbers with decimal format. So we can say float f is equal to 3.1415 and so on. And this 3.1415 will become the fixed value in the code, which means it is also a literal. And since this does not belong to the integer category, it means literals do not support just integers. It also supports floating point numbers. And going by the same logic, it supports characters, booleans, and string as well. So in conclusion, literals are not just integers. They can be floating point number, they can be characters, they can be boolean, and they can be string. Let us discuss about each of them one by one. And let's start off with integer literal. Now, what counts as an integer literal? Any number without the decimal point, irrespective of the number system that they are in, counts as integer literal. And what I mean by this is 10 base 10, which means this is in decimal number system, counts as a literal. And so does 0110 base 2. And similarly, 25 base 8 and 1AF base 16. All of these counts as integer literals. Now, I'm assuming that you're familiar with different number systems that we have. That is decimal, binary, octal, and hexadecimal. And you also understand the conversion between them. If you don't, the same playlist in which this video is contains a dedicated video explaining the different number systems and the conversion between each one of them. Continuing, like I said, any number without a decimal point, irrespective of which number system they are represented in, counts as integer literal. Now, we also know that a number in decimal number system can be written without any base, but the same does not hold for numbers in other number system, for example, binary, octal, or hexadecimal. So the next question that arises is, how are we going to write these numbers by specifying the base? And if we don't specify the base, how is the compiler going to identify if this is in binary or decimal? Let's find this out. For that, what am I going to do is create a new Java class and name this literal. And over here, I'll have a public static void main method. Now here, I'll create a variable of int type and store some value. So let's say I go for int v1 is equal to 10. And what am I doing over here is I'm creating a variable v1 and I'm saying that this will hold int values, and currently I'm assigning 10 to it. So if I want to print the value of v1, what can we do is I can say system.out.println and put the name of the variable, which is v1 in our case, and run the code. And we can see that it is printing hello world again. Okay. So let's change this to current file and let's run the code. And it gives us 10. Now, what if I need to create another integer variable and assign a value to it, but this time I want to go for the binary number system. So for that, this is what we can do. I can say int v2 and give an equal to operator, and then I can type in 0110. But we know that 0110 is in binary number system. How do we tell it to the compiler? For that, we can put 0 small b at the beginning of 0110. And if I print the value of v2, what do I expect? Well, let's see. If I run the code, I get 6 printed over here. And if you're familiar with conversion from binary to decimal, you know that 0110 is 6. So what's happening over here? So when we put v2 in system.out.println, irrespective of which number system the value of v2 is present in, it gets converted to decimal number system. And that is why we are getting 6 over here, which is the binary to decimal conversion of 0110. Next, let's see how can we create another variable of int type and assign a value to it, which is in octal number system. So for that, we can say int v3 given equal to, and say I want to put 27. But if I just leave it at 27 and I print v3, I will get 27. But what we wanted was to put 27 as an octal number. So for that, we will have to put 0 at the beginning. And now if I run the code, I get 23, which is the octal to decimal conversion of 27. Because 7 is at 0th position, its value will be 7 multiplied with 8 power 0, which is 7. And 2 is in position 1, its value will be 2 multiplied by 8 power 1, which is 16. And combinedly, it will be 16 plus 7, which is 23, which is what we are getting. Now, let's see how can we do the same thing for a number in hexadecimal number system. For that, we'll create another variable. We'll say v4 and we will say 1af. And if you see, we are getting an error over here, and it is because af does not seem to be the correct value along with 1 to be assigned to v4. And this is happening because we have not specified that what we want to do is we want to put a number in hexadecimal number system. So for that, we can say 0 x at the beginning and the error goes away. And if I try to print the value of v4, we get 431, which is the hexadecimal to decimal conversion of 1af. So this is how we can have integer literals in different number systems in our code. Also, before continuing, there are a few more points that I want to talk about. You see, we've got 0b over here where b is in small letter. So here, even if we put capital B, it won't matter. If we run the code, we get the same output. And the same thing applies to this x as well. If I put capital X and I run the code, I still get 431. So I hope you've been able to understand this. And if you do, let me ask you a question. So what if I say int v5 and I assign 09 to it? Now it is giving an error because a semicolon is missing. But what would happen if I put a semicolon? Pause the video, let me know your answer in the comment, and then resume the video to find if your answer matches mine or not. So if I put a semicolon over here, we are still getting an error. And this is happening because putting a 0 at the start made it a number in the octal number system. And if you remember, octal number system supports digits from 0 to 7. which means 9 is out of range of the digits allowed in octal number system. And that is why we are getting an error over here. So continuing, these are integer literals, which means they are fixed numbers in our Java code without a decimal point, which means we can assign it to the data type that belongs to the integers category. Now, there are four data types in the integers category: byte, short, int, and long. But whenever we create an integer literal, it is always int, not byte, not short, and not long. So is that okay, or could that cause some problem? Let's see. So if you recall, we've got byte, short, int, and long in the integers category in the data types. And all of them has got certain range of values that they support. Byte supports values from -128 to 127. Similarly, short has got a range, int has got a range, and long has got a range. Now, if integer literal internally creates int value, it is fine for numbers that fall in this range. That is from -2147483648 all the way up to 2147483647, because the range of short falls under this range, and so do the range of byte. But what if we need to create an integer literal which is beyond the range of int? So let's say we want to use this integer literal 21474833 say 700. If you compare, this is beyond the range of values allowed in int, and it falls under the range of values allowed in long. In that case, will it work or will it cause some error? Let's find that out. So for that, what am I going to do first is get rid of statement on line number 15. And for that, I'll just comment it out. And then in the next line, I'll say int v6, and I'll say 2147483700, and I'll put a semicolon at the end. And as you can see, we are getting an error. And the error is because this number is beyond the range of values that is supported by int. But if I change it to, let's say, 647, that error will vanish. But if I revert it, we will get that error back. And this is happening because the number 2147483700 is an integer literal, which we have assigned to a variable of type int, but the number falls beyond the range of values that are supported by int. Now, what can we do to solve this problem? So since it falls beyond the range of int, but falls within the range of long, what we will have to do is we will have to change the data type of v6, and we will have to say long v6. But if you see, we are still getting an error. And why is that happening? Again, that's happening because this integer is being treated as int. The Java compiler still does not know that this number should be treated as a long and not an int, because we have not changed anything over here. All that we had changed was the type of v6 from int to long. The compiler is still treating this as an int literal and giving an error because this falls beyond the range of int. So we'll have to tell the compiler to treat this as a long literal. For that, we can put L at the end and the error will go away. Now that error has vanished, but we can still see a yellow line over here. And if we hover on this, it says long literal ends with lowercase l, which is not an error. And that is why if we compile and run this code, it will execute just fine. It does not print anything because we have not put a println statement. But if we add that and then run the code again, we will get whatever we had assigned. However, by convention, capital L is preferred instead of small n. And the moment we put that, that yellow line vanishes. And if I run the code now, it will still give me the same output. So this is how we can specify to the compiler that a particular literal should not be treated as an int literal, but should be treated as a long literal. Also, if you take a look at this statement on line number 7 and specifically focus on the number that we have, this is pretty long and it is harder to read. So to solve that problem, Java gives us an option of putting underscores between the digits to make it easier for us to read. For example, I can put an underscore over here and here and here. And now this is much easier for us to read. This has become 2,147,483,700. And it is not mandatory to put underscores this way. You can put underscores any way you like. For example, you can say 214 underscore, then 74 underscore, and then 83 underscore, and then 700. And now this has become 214 crores, 74 lakh, 83,700. Also, you can put multiple underscores between digits. So you can say 214 double underscores, then you can also say 74 double underscore. And if you run the code, it will work just fine. And if you've noticed, the output does not contain underscore, and that is because underscores are used to help make the code easier to read. And the compiler ignores them when compiling and uses the number without underscores. And that is why we are getting the output printed without underscore. Also, if you have noticed, we've used a combination of double underscore and single underscore, and there's no error, and that is because it is allowed. However, what is not allowed is putting an underscore at the beginning of the number. And you see, we're getting an error right now. Similarly, what's not allowed is putting an underscore at the end of the number. So we are getting an error right now, and it says illegal underscore. Even if we put the L back, we will still get an error saying illegal underscore. Also, the usage of underscore is not limited just to numbers in the decimal number system. We can very well use it for numbers in any number system. So let's see that in action. Let's take the statement in line number 6 for an example. We've got 0, 1, 1, 0. Let's say we add 1, 0, 0, 1, then 0, 0, 0, 0, and then 1, 1, 1, 1. Now, what if we want to group this in 4? We can put underscore over here after 0, 1, 1, 0, and then another underscore after 1, 0, 0, 1, another one after 0, 0, 0, 0. And if I run the code, you can already see that there's no error. And if I run the code, we get the output that we expected. We are getting 26895, and that's because the binary to decimal conversion of this number is 26895. We can do the same thing with octal and hexadecimal. Now I'm not doing this over here, but you can go ahead and try it on your own. Next up, let's talk about floating point literal. So far, we've been writing floating point literal as this 3.14159. And this way of writing a floating point literal is called standard notation. However, there's another way in which we can write floating point literal, and that is called the scientific notation. Let's talk about what this is before we proceed. So scientific notation contains something called mantissa, then a capital or a small e, and then exponent. This is the general format of a floating point literal represented in scientific notation. So how can we represent this in scientific notation? For that, let's take a general example. Let's say mantissa is A, and we are putting a capital E, and we are putting exponent as say X. So this translates to A multiplied with 10 power X, or mantissa E exponent will translate to mantissa multiplied with 10 power exponent. So if we were to represent 3.14159 in scientific notation, we will have to think of a way to represent it as mantissa E exponent, where it will evaluate to mantissa multiplied with 10 power exponent. So let's see how to represent 3.14159 in scientific notation. So can we say 3.14159 multiplied with 10 power 0? Yes, because 10 power 0 is 1, and a number multiplied with 1 is the number itself. Or can we also say 31.4159 multiplied with 10 power minus 1? Because 10 power minus 1 is 1 by 10. And if we divide this number by 10, we will get 3.14159. We can also say 314.159 multiplied with 10 power minus 2, and so on. Or we can also say 0.314159 multiplied with 10 power 1. All of these are different ways in which we can write 3.14159 in scientific notation. Now, what will this translate to? This will translate to 3.14159 E, whether capital or small, and then 0. This will translate to 31.4159 E minus 1. This will translate to 314.159 E minus 2. And this will translate to 0.314159 E1. Now, you must be wondering that with all of these options to choose from, and there are of course more, how should we represent a floating point number in scientific notation? So you can choose any one of them, but the length of the mantissa directly determines the precision of the number. Now, this is not very important to get into right now, and that is why we will not discuss the details for now. But if you want to understand, let me know in the comments, and there of course can be a separate video explaining this. Most of the time, we would be representing floating point literal in standard notation itself. But knowing about scientific notation is not a harm, right? Also, before we proceed, let me tell you that similar to integer literal defaulting to int and not byte or short or long, floating point literal will default to double and not float. But of course, there's a way in which we can tell the Java compiler that the floating point literal that I have put should be considered a float and not double. So now let's jump to code and see all of this in action. So the first thing that I'm going to do is create a variable of float type and say v7, and I'm going to assign 3.14159. And the moment I put a semicolon, you can see that we are getting an error. And this is happening because 3.14159 defaults to double, but we're trying to assign it to a variable which is declared of float type. Now, more specifically, this is happening because there's a mismatch in the value and the type of variable that the value is assigned to. Over here, a double value cannot be put in a float variable, and that is why this error is coming up. We're going to talk more about it when we talk about type conversion. For now, let's see how can we specify that 3.14159 is a float literal and not a double literal. For that, we can put a small f or a capital F at the end. And as you can see, the error vanished. Now, if I print the value of v7, what do I get? Well, I get 3.14159. And if I change this to small f, I'll get the same value. But if I create another variable of double type and do the same thing, as in assign 3.14159, there's no error even without putting anything after 9. And that is because, as we know, 3.14159 defaults to double. So we can put a small d or a capital D to represent that this is a double literal, but that is redundant. It will work even with the d removed. So if I print the value of v8, I get 3.14159. Now let's put 3.14159, but not in standard notation, but in scientific notation. So for that, let me create a variable of type float. Let's name the variable v9, and let's say I go for 31.4159e minus 1, and I put a semicolon at the end. And we are getting an error, and the reason for the error is same. It says required type is float, but we have provided double. So what we will have to do is we will have to specify that this is not double, this is float, for which we can put a small f or a capital F at the end. And if I print the value of v9, the last three lines of output will be 3.14159. We can do the same thing with a double variable. So we can say double v9. And now if we leave the f over here or we remove the f from here, we are not going to get any error. And that is because we have put the data type of v9 as double, and the rules of type conversion allows this. So again, without going into details of type conversion for now, let's run the code and check the output. And we are getting 3.14159. Also, as was the case with integer literal, where we had used underscores to separate the digits and make it easier for us to read, we can do the same thing with floating point literal as well. So if I put, say, 3.141 underscore 59 over here in line number 23, or we do the same thing here in line number 20, there's no error. And if we run the code, it works fine and gives us the same output. We can do the same thing in scientific notation as well. For example, if I put, say, 3 underscore 1.41 underscore 59 and then run the code, it works absolutely fine. And the reason is that Java compiler ignores the underscores between the digits when compiling. Another point over here is the same rule of not putting the underscore at the beginning or at the end of the literal holds. So if you say underscore 3 underscore 1, it will give an error. Same way, if you say 3.141 underscore 59 underscore f, it will give an error, and the error will read illegal underscore. Next, let's talk about Boolean literal. For a Boolean literal, there are only two possible values, true and false. Also, some programming languages treats true as 1 and false as 0, but this is not the case with Java. In Java, true is true and not 1 or any integer for that matter, and false is false and not 0. So Over here, let's create a variable of type Boolean, say v10, and let's assign true to it. And let's print the value of v10 and see what do we get. We're getting true. If we change this to false, we will get false as the output. And that's what we got. Next, let's talk about character literal. The first point to talk about here is that a character literal is represented inside a pair of single quotes. For example, dollar or one or a hash or let's say small a or capital A. So in short, all of the characters that you see on your keyboard can be put inside a pair of double quotes. There's some exception to it, which we will get to in a moment, and we will also understand how to get over those exceptions. So first of all, let's create a variable of type char. Let's name the variable v1 and let's say dollar in a pair of single quotes. And let's print the value of v11 and we get dollar printed over here. If I change this to 1, we will get 1 printed over here. If I change this to say a capital A, we will get capital A printed over here. Now I said that all of the characters visible on your keyboard can be put inside single quotes. And I also said that there's an exception. So let's talk about that exception now. Now, one of the characters visible on your keyboard is the single quote itself. So what if you want to print a single quote? Is that possible? Let's say I put this. Now, if we take a look at it, it looks like there's an opening single quote and there's a closing single quote and there's a single quote between those opening and closing single quotes. So if I run the code, it should be able to print the single quote, right? But as you can see, we are getting an error and we are getting an error because Java compiler does not know that this is the start or open single quote. This is the end or the closing single quote, and this one is supposed to be printed. It is treating this one as the open single quote and this one as the closing single quote. And this is seen as a mismatch. So what we will have to do is we will have to tell Java compiler to not treat this literally, as in not treat this as an open or a closing single quote, but treat this specially. And for that, we need to put a backward slash. And the moment we do that, the error vanishes. And if I run the code now, I get a single quote printed. So this is what the backslash helps us do. It helps us tell the compiler to not treat a particular character literally as it is supposed to be treated in Java, but treat it specially. And this backslash is called escape sequence. Now another example, let's say you want to print this backslash because we use backslash for escaping a particular character, as in telling the Java compiler to not treat it literally. How would we print the backslash itself? Because the moment we put backslash in a pair of double quotes, you see we are getting an error, and we are getting an error because Java compiler is treating this one as the open single quote, the backslash and this single quote as an escape sequence, which means the single quote should not be treated literally. And it is seeing that this particular assignment has a closing single quote missing. So what we will have to do is we will have to escape this backslash. Because we want to print backslash, we will have to tell Java not to treat it literally, as in not to treat it as an escape character. So for that, we will put a backslash before this one. Now, if I run the code, I get a backslash as the output. So this is how we can print backslash. Now, let's talk about another interesting thing about character literals. If I create a character variable, say v12, and I put, for example, 97, you see we're not getting any error. But what will be the output if I print v12? Let's find out. We are getting small a. If you remember from the video where we discussed about string representation, we talked about Unicode characters and we specifically focused on ASCII, where ASCII stands for American Standard Code for Information Interchange. Over there, I had told that uppercase A or uppercase Z or Z, as we commonly called it, are assigned numbers from 65 all the way up to 90. Lowercase a to lowercase z are assigned numbers from 97 to 122. So when we say 97 for a variable which is of character type, it is internally converting this 97 to the character associated to 97, which is small a. And that is why if we change this to, let's say, 122 and run the code, we get small z. If we change this to, for example, 66, we will get capital B. And that is what we got. Likewise, If I go for an int variable, say v13, and I assign a character to it, for example, capital A, you see we are not getting any error. And I think you must have guessed what the output here will be if I print v13. Since capital A is assigned 65, if I run the code, that is what we are getting. If I change this to say capital Z, we get 90. Similarly, if I change this to small z, we will get 122. And if I change this to, for example, 0, I get the value or integer assigned to 0, which is 48. And that is what we have got. Lastly, let us talk about string literal. Like character literals are enclosed within a pair of single quotes, string literals are enclosed within a pair of double quotes. For example, hello, comma, world. This is an example of a string literal. So let's create a variable v14, which will be of type string, and we will say equal to, and within a pair of double quotes, we'll say hello, comma, world. And what are we going to do next is print the value of v14. And if we run the code, we get hello world as the output. Now, what if I want to print hello world, but with double quotes, as in I want the output to be hello world inside a pair of double quotes. For that, if I add a double quote over here and over here, we are getting an error. And that is because Java is treating this one as the opening double quote and this one as the closing. So again, similar to character over here, we'll have to tell Java to not treat this literally, as in not treat this as the closing double quote. And for that, as you might have guessed, we are going to use backslash. So the error from this part vanished. And we will have to do the same thing over here because we want to escape this double quote and not the last one because this is the closing double quote. And now if I run the code, I get hello world printed within a pair of double quotes. Now another question. Let's say I want to print hello world, but what I want to do here is print hello on one line and world on the next line. What can we do? Well, can I say hello on one line and world on the other? Well, as soon as I pressed enter, what IntelliJ IDE did was split this into two string. Now the plus that you see over here is not used for addition because of course we cannot add string, but we can do something called concatenation where we join two strings. For example, Java programming or hello world, or it also applies to more than two strings. For example, my name is this. So if I run the code now, we will get hello world printed, but on the same line. Even if you put one string on one line and the other one on the other, Java will consider them to be on the same line. But if you still want to do it somehow, what can you do? Let's undo this change first of all. Now, if I want to print hello on one line and world on the second line, what we can do is we can use \n. So what will happen on putting a /n is Java compiler will understand that the cursor has to be shifted to a new line before world is printed. So it will print hello, comma, then shift the cursor to the new line and then print world exclamation mark. So if we run the code now, we get hello and world printed on different lines. Now, is this the only way to do it? Well, no. There's something called a text block which we can use. So let's see how can we do so. Let's say we have a string variable v15 and over here we are going to use text block. For using text block, we need three pairs of double quotes. And within these three pairs of double quotes, we can write whatever we want to print and we can write it however we want it to be printed. For example, if I want hello, my name is Sagar, I'll write it this way. And on the next line, if I say system.out.println v15 and I run the code, I get hello on one line, my name is on another line, and Sagar on the last line. So this brings us to the end of the video. Summarizing, we learned that there's something called literals, which refers to the fixed value that we have in our code. And literals may not just be integers. They can be integers, they can be floating point numbers, they can be character, they can be Boolean, and they also can be string. So I hope I've been able to teach you something new and useful. If you have any queries, suggestions, or feedback, please feel free to put them in the comment. Thank you so much for watching, and I'll see you in the next one.